Hello again. We're going to be doing problem 9 of the practice problems for module 4. If you watched the last video, you might see a few familiarities in this equation. But let's take a look. So first of all, we're supposed to balance that equation that is written right there. And it's already given to us. We don't have to figure out what elements we need to use and all of that. But let's take a minute to notice a couple of things. Number one, as I said, if you watched the video for problem 8, you might recognize this element. You would recognize that it is heptane, liquid heptane, CH, or C7H16. But another thing that we should notice, certainly, is that this is a combustion reaction. We're adding gaseous oxygen, and we're getting CO2 and H2O out of the reaction. So this is actually the combustion of heptane. Now we can take a look at how we're going to balance this equation. So generally a principle I say to use is to start with the largest elements and see if you need to change them. But let's go ahead and just assess whether we really are unbalanced here and where we are unbalanced. We see that there is if we start with the C's, there's 7 C's over here. So that's the entirety of the left side is 7 C's. On the right side, all I can see is 1 C. So we know we're definitely going to have to change something there. We can look at the H's. We have 16 H's on the left side, and that's the entirety of the left side. And if we look to the right, we can see we have 2 H's. So that's definitely unbalanced as well. If we look at the O's, we'll see we have 2 O's on the left side, 2 O's here, but also a third O, so we have 3 compared to 2. So every element is actually off in this equation. So we're definitely going to have to balance this equation. So let's go ahead and do that. Now generally, like I said, we start with the larger elements and see if we need to change anything here. If we look at the C's, we had 7 on this side and we had 1 on this side. So we're probably not going to need to multiply this by anything to match the right side since it's already larger. But let's go ahead and take a look at the H's just in case. With the H's we have 16 and we said we only had 2 on this side. So definitely since this one has many more atoms than are on the right side, we definitely won't have to change that one just yet anyway. Then we can move on to some other larger elements. So let's go over here and look at the CO2. We're going to skip this O because it's a single element. And with single elements, they're really easy to change at the end of an equation. So we don't need to change that just yet. Let's move on to CO2. We have 2, and then we had a third oxygen on the right side compared to the O here. So as far as the O's, we're probably not going to need to change anything. But if we look at the C's, this is the only C we have on the right side. And we have to make it somewhere on the right side. We have to make up for 7 C's on the left. And so, since this is the only C we have on the right side, we know we're going to have to multiply this by 7 in order to get those to match. So we'll go ahead and do that. And I'm just going to write the arrow here and fill in the rest of this equation. Alright, so now if we fill in the rest, we would see that we have 7 C's on both sides. But now we didn't just change C's, we changed O's. So let's take a look at that and see if there's anything we need to fix. Now if we multiply this, we'll see that we have 14 O's plus a 15th. And that's definitely a lot more than what we have on the left side. But since we would only change a single element, we will wait to change the O's for now. And let's move on to the next largest element, which is H2O. For the H2Os, again, we'll change the O last, so we won't mess around with the O too much for now. But let's take a look at the H. So we have 16 H's on the left side and only 2 on the right side. So we know we're definitely going to have to change this molecule to make it match. And since this is the only H on the right side, it's definitely going to have to be this molecule that we change. So let's go ahead and change that. We'll have to multiply it by 8 in order to get 16. and I'll fill in the entire rest of the right side. And so now we have 7, we have 8. Let's take a look at what else we might need to change. So let's start over and just count our atoms to see what's still matching and what may not be matching. So the 7s, or the C's I should say, we have 7 of each on the left and right side, so our C's are matching up. That's great. Let's take a look at our H's. We have 16 H's on the right side, and we have 16 H's on the left side, 16 H's on the right side, and so those match up as well. So now we just need to match up our O's. If we take a look again, we have 14 for this molecule, and we have now 8, so we have a total of 22. That would be 7 times 2 equals 14, and 8 times 1 is 8. 14 plus 8 is 22. So we have 22 O's on the right side, and we only have 2 on the left side, so we're definitely going to have to change that. And we left the element for last because it's easy to change. If I just want to make 2 O's into 22 O's, I can just multiply all of that by 11. And it was really simple. Now, don't get this mixed up and say that this is 110. It's not. We got to be a little careful when we write letters and numbers together. Often when I put a 0, I would put a slash through it. But often when you're writing and balancing chemical equations, you won't really deal with the number 0 too much. So we won't really have to worry about that. Just watch out for that. And then if we fill in the rest, we'll have our entire balanced chemical equation. And if you wanted to, you could go back and recount that all of those are correct, but we know that they are, so we'll leave it at that. And that's the balanced chemical equation for the combustion of heptane.